So the next lecture is going to talk about t-tests. So to give an overview, we're going to talk about trying to compare the differences between two groups. Then I'll introduce the concept, the statistic of a t-test. Then I'll talk about how to use a t-value. Then we'll talk about SPSS and how to make sense of a t-test in SPSS. And then we'll talk about the different types of t-tests, because depending on your design of your study, you'll use different types of t-tests. So as we've established, the goals of an experiment is to establish cause and effect relationships. And what we're trying to see is if our independent variable has systematic effects on the dependent variable. So in other words, we're trying to see if one group systematically differs from another group. One condition systematically differs from another condition. And we want to be able to determine if that difference we see between our groups is due to our independent variable, what we've manipulated, or if it's just due to random error, just kind of individual differences between participants, measurement error, sampling error, any kind of error that, any kind of change between your conditions that's not due to the independent variable is going to be called random error. And what we're trying to do is we're trying to determine if the differences between our groups are due to the independent variable or due to random error. So a thought experiment. So let's say you had two groups of the same plant, right? So you have these two plants. One is going to be our control condition, and the other is going to receive this new fertilizer, right? So we have our control condition on the left, the fertilizer on the right. So one group of plants is going to get the control, one's going to get the fertilizer. Then after the experiment, you measure the plants and of both groups, and you realize that your treatment group, the ones that got the fertilizer, are 10 centimeters taller than those in the control group. So the average of your fertilizer group are 10 centimeters taller than the average of your control group. Does this provide you with good evidence that the fertilizer caused the plants in that one group to do better than the plants in the control group? And the reality is it all depends on the variance of the plants. So how varied they are between each other. So we have differences between our groups or our conditions, and that essentially is looking at, does the mean for one condition differ from the mean of another condition? All right. And for the null hypothesis, it would say that the mean for one group was the same as the mean for the other group. So M1 equals M2. And again, that's saying that the independent variable had no effect on the dependent variable. The alternative hypothesis would be that the groups are not the same. So one of the two groups is higher than the other. And this would be considered a two-tailed test because we're not saying which one is going to be higher than the other. We're saying they're going to be different, right? If I wanted to make a one-tailed test, I would give it direction. I would say the mean for group 1 would be higher than the mean for group 2. But for this particular example, we're just saying that the means are going to be different. If we're talking about our fertilizer versus the control condition, we're arguing a one-tailed hypothesis that the plants that got the fertilizer are going to do better than the plants in the control condition. And this is basically saying that the independent variable had an effect on the dependent variable. All right, so again, we're trying to compare the variability of the groups. And we have two different types of variability that we're trying to deal with. The variability between the two means of the groups and the variability around those two means. The variability between the groups is if you look at it here, it's the green. This is the mean for the green group. This is the mean for the blue group. It's just the difference between those two means. The variability within the group is how the scores vary around our two means, right? And what we're trying to do is we're trying to form a ratio. And you'll see this as we go through and talk about t-tests and also talk about f-tests. We're looking at between group variability, so the difference between our means, and within group variability, which is the variability around those means. And we form a ratio for this. So let's do a couple of demonstrations and see if this will start making more sense to you. So I want you to look at the numbers for condition A and condition B, and we're trying to figure out, do you think if condition A is significantly different from condition B? So what I want you to do really quickly is to calculate the mean and the range for these two groups. And I arrange the numbers in a way in which it's very easy to figure out what the mean is. All right? So for condition A, the mean is 50, right? 49, 49, 50, 51, 51. The mean is 50. And the range is 2. Remember, the range is the highest minus the lowest. For condition B, the mean is 60. And we have a range of 2 again. So hang on to these numbers. We're going to come back to them in a minute. Now, we're going to do the exact same thing, but now for conditions C and D. And we're trying to figure out, are conditions C and D different from each other? So again, calculate the mean and the range for both of those conditions. All right, so for condition C, the mean again is 50. Now the range is 12. For condition D, the range again is 60 and a range of 12. Hang on to these numbers. So far for A and B, we have 50, a mean of 50 and a mean of 60, and a range of 2 for both. For condition C, we have a mean of 50. For D, we have a mean of 60 and a range of 12 for both. So the question again is, are conditions A and B different from each other, and are conditions C and D different from each other? And the question is, how do you know if they are significantly different from each other, right? Because the difference could be just due to random error. We want to know, is this difference between our means, is that due to whatever our manipulated independent variable is? And the key to figure this out is to determine the variability between the groups, which again is called between group variability, right? And the variability within each of the groups. So how much does the scores vary around the means for each of the groups. And that's within group variability. All right, so again, to determine if there's a difference between the groups, you're going to just basically subtract one mean from the other. So we're just going to take the difference of our two means. So for demonstrations for conditions A and B, which is 60 minus 50. For C and D, again, it's 60 minus 50. For both, the differences between A and B and C and D are going to be 10. So hang on to those numbers. The larger the difference between the means, the more likely it is that the groups are going to be statistically different from each other. Now, that's not the only factor you have to take into account, but everything else being held the same, larger differences between the means are going to be more likely to lead to statistically different differences compared to when the means are close to each other. All right, so that's the variability between the groups. Now let's deal with the variability within the groups. So to determine the variability within the groups, you want to calculate the amount of variability there are around your means for your different groups. Typically, we deal with standard deviations when we're talking about variability, but that's a harder concept for you to grasp for this example, and I want to keep it simple, so you're going to use range. Range, again, is not the ideal way of measuring variability, but for this demonstration, it serves its purpose in being simple, so just don't get too bogged down by that. All right, so for condition A, we had a range of 2. For C, we had a range of 12. So like A and B, we had ranges of 2. For C and D, we had ranges of 12. Now, for this, the less variability there is within the groups, the more likely the groups are going to be statistically different from each other. So again, holding everything else constant, smaller within group variability is going to lead to more likely to have statistically significant results compared to larger within group variability. And again, we normally deal with variability when we're talking about standard deviations. We don't typically use the range. All right, so let's go back to our first demonstration, A and B. So our variability between our groups is 10. right? So it's the difference between 50 and 60. The variability within our groups is 2. And what we're going to do now is we're going to create a ratio out of this. So 10 over 2 gives us a value of 5, right? So that says that the variability between the groups is much greater than the variability within the groups. In this example, it's 5 times greater, right? And with the sample size of about 60, anything that's going to be basically about 3 times, 2 or 3 times the between group variance versus within group variance, it's going to be statistically significant. So whenever you get that ratio to be around 3, you're going to have a statistically significant result if you have about 60 or more people. If you go back to C and D, again, if we have the same between group variability of 10, and then within is going to be 12. When we calculate that ratio, we're going to get a value of 0.83, right? And it's a very small number because there's more variability within the groups than there is between the groups. And again, the larger this ratio, the better, right? So you want that when you calculate that ratio, you want the larger the number, the better it is, the more likely you can attribute that difference between the groups to be due to the independent variable. And there are a couple ways to make that ratio larger. You can increase the numerator, so making the difference between the groups larger, right? So if I have a ratio of 1 to 1, that gives me a value of 1, whereas 5 to 1 gives me a value of 5. 10 to 1 gives me a value of 10, right? You can also make the ratio larger by decreasing the denominator, right? So ratio of 10 over 10 gives you a value of 1. 10 over 5, all of a sudden now we have a value of 2. 10 divided by 1, we got a value of 10.